Hi everyone, thanks for joining us. Today we will be exploring simple tests used to identify anions and cations. What are anions and cations? If you don't know what anions and cations are, on this channel we have a video on anions and cations. If you don't mind, you can scroll down and check on their video. Now, to test for cations and anion, the very first test we'll be looking at when testing for cations is the flame test. And this flame test is possible because certain metal ions give characteristic colors to the flame. Example, we have sodium ion that produces a persistent golden yellow with a flame. We have calcium that gives a brick red or orange red flame. We have lithium that gives a deep red flame. We have strontium that gives a crimson flame. We have barium that gives an apple green flame. And we have copper 2+ that gives a bluish flame. For the procedure in carrying out the flame test, we have a video on that on this channel. Scroll down and look at the procedure. Now let's go to what we have on the paper. This is a summary on this topic. I just summarized everything. Now we have ions, we have test reagents, observation, and confirmatory test. The first three ions we have are the chloride ion, the bromide ion, and the iodide ion. These are ions from the halogen series. Now, what reagent do we use to test for the presence of the halide ion in a compound? The reagent we use is acidified silver nitrate plus ammonia. When you add acidified silver nitrate to the test substance, and if chloride ion is present, we are going to see a white precipitate. If the bromide ion is present, we are going to see a cream precipitate. If the iodide ion is present, we are going to see a yellow precipitate. Now, if you go into an examination hall and you see a reagent as silver nitrate, acidified silver nitrate and ammonia, what you should have at the back of your mind is that they are testing for the halide ions. Further information will tell you which ion exactly they are tested. If they said white precipitate was of a white precipitate, if they further tell you a white precipitate was observed, what you should know is that the chloride ion was present. If the information further says a cream white precipitate was observed, what you should know is that, or your inference should be that the bromide ion is present. And if it says a yellow precipitate, what you know is that the iodide ion was present. But they might decide and don't even give you the color of the precipitate. They might further give you the information. They might further give information about the solubility of the precipitate in ammonia. After adding ammonia, what happens? After adding ammonia in the precipitate form, it becomes soluble. The precipitate was soluble in ammonia. They can give information about the solubility of the precipitate in ammonia. If they say the precipitate was soluble in ammonia, you know that it is chlorine. If they say a precipitate was produced, without giving you the color, and that precipitate was soluble in ammonia, you know that it is a chloride ion. And if they say a precipitate was produced without giving you the color, and they say that precipitate was sparingly soluble in ammonia, you know that is the bromide ion. And if they say a precipitate was observed without giving the color, and that precipitate was insoluble in ammonia, you know that it is the iodide ion. So the halogens can be tested in two different ways, either using their colors or their solubility in ammonia. Now, let's go to the test for the ion 2 ion and the ion 3 ion. The ion 2 ion, and the ion 3 ion. And the reagent we use for that is sodium hydroxide or ammonia. So if you are carrying out an experiment or you are answering a question and you see sodium hydroxide or ammonia as the test reagent, what should come to your mind, or what should be at the back of your mind, is that they are testing for the iron 2 ion or the iron 3 ion. Now the observation will tell you which of the ion is present in solution or is present in the test sample. If they say sodium hydroxide was used or ammonia, and what was, or aqueous ammonia, and what was observed was a dirty green gelatinous precipitate, a dirty green gelatinous precipitate, your inference should be that iron 2 ion is present. And if they tell you that a rot brown or a reddish brown gelatinous precipitate was observed, what you should have at the back of your mind, or your inference should be that iron 3 ion was present. Let's move further to the sulfate and the sulfite ion. To test for the sulfate and the sulfite ion, the reagent used is barium chloride plus hydrochloric acid. Further test or observation will tell you if it is the sulfate ion or the sulfite ion present. The sulfate ion will produce a white precipitate which is insoluble in the acid, in excess hydrochloric acid. Meaning, this white precipitate, if you add excess hydrochloric acid, is not going to be soluble, it's not going to dissolve. It remains insoluble. But now, when you add excess acid, when you add excess hydrochloric acid in the sulfite ion, what happens? It produces this gas, sulfur dioxide gas is produced. Sulfur dioxide gas is produced. Summarily, we are saying that if you see a test reagent as acidified barium chloride, what should come to your mind is that they are testing for the sulfate and the sulfite ion, and all of them will produce a white precipitate. If the test further says a precipitate was insoluble in excess acid, you know that it's the sulfate ion. If the information further says a gas was produced that changes orange dichromate to green, or changes purple potassium permanganate to colorless, you know that it is sulfite ion. Now let's go to the nitrate ion. It's just one test, the nitrate ion, which we use ferrous sulfate. You are going to observe a brown ring at the center of your test tube. That's the test for the nitrates. Brown ring, nitrate, that should be at the back of your mind. The test for the carbonates, you add either hydrochloric acid or nitric acid. Effervescence will be produced. We can liken effervescence to like when you put effervescent in water, and the effervescence produces a gas called carbon dioxide. Further test, how can we test for carbon dioxide? Carbon dioxide is the only gas that turns lime water milky. Water, how can we test for the presence of water in a sample? We use anhydrous copper 2 sulfate. We use white anhydrous copper 2 sulfate. And if the test substance contains water, that white anhydrous copper 2 sulfate is going to change to blue. Now we have a blue hydrated. Hydrated means water is present. Ammonia is a colorless pungent gas that turns moist litmus paper to blue. Say it is turning a litmus paper to blue, it is a base. Characteristics of bases: they turn moist litmus paper blue. Characteristics of acid: they turn moist litmus paper red. Now, let's take a quick look at this question. Section B, answer all questions in this section. In order to determine the chemical composition of salt R, a student carried out a series of tests using the... When you see acidified silver nitrate, you just know that they are testing for the halide ion, the chloride, the bromide, or the iodide. Aqueous ammonia. When you see aqueous ammonia, what should come to your mind? They are either testing for iron 2 plus or iron 3 plus. All the reaction takes place in the test tube. And materials for flame test. We have materials for flame test. Okay. 1. A flame test is carried out on source R and a bluish green flame observed. Briefly describe the test procedure. Procedure for carrying out a flame test, we have a video on that. If you haven't seen, try and go over. What does the bluish green flame indicate? When we observe a bluish green flame, that indicates the presence of a copper 2 ion. A portion of salt R is dissolved in distilled water. To 2 cm³ of the solution in the test tube is added 2 drops of acidified silver nitrate, followed by excess aqueous ammonia. Complete the table below. Now, presence of chloride ion. What is the observation? From what we had, this is our chloride ion. What is the observation? A white precipitate. White precipitate. If we had bromide ion here, our observation will be a cream precipitate. We have iodide ion, our observation will be yellow precipitate. Identified salt R. The cation we have identified here is copper 2 plus, and the anion we have identified here is chloride ion. When copper ion and chloride ion combine, what would they give? They will give us copper 2 chloride. Identifying the salt, our salt is copper 2 chloride. You are given a salt sample labeled iron 2 nitrate. Complete the table below by giving the test procedure and observation made to confirm the identity of the salt. Our salt is iron 2 nitrate. What is our cation? Iron 2. Our anion, nitrate. We can test for the presence of iron 2 ion using sodium hydroxide. Here we are going to have dirty green. See, it is iron 2. If it was iron 3 here, we'll have rust or reddish brown gelatinous precipitate. But since it is iron 2, we have dirty green gelatinous precipitate. What is our anion? The nitrate ion. How do we test for the nitrate ion? We test for the nitrate ion using iron 2 sulfate. From what we saw earlier, we use iron 2 sulfate. And what is the observation? Nitrate, brown ring. We observe a brown ring at the center of the test tube. This is another question, a similar question. Let's look at it. In order to determine the chemical composition of 2 salts, A and B, and an organic compound O, a student carried out a series of tests using the following: aqueous barium chloride. When you see barium chloride, what comes to your mind? Sulfates or sulfites? When you see barium chloride as the test reagent, what should come to your mind is the presence of the sulfates or the sulfite ion. Dilute hydrochloric acid, aqueous sodium hydroxide, solid PCl5. This PCl5 is used to test for the presence of organic compound. And materials for flame test as usual. A flame test was carried out on salt A. A lilac flame color was observed. Briefly describe the procedure for flame test. We have a video on that. Please watch it. What does a lilac flame color indicate? Lilac flame color indicate the presence of the potassium ion. We have a video on that. To 2 cm³ of solution A is added 2 drops of aqueous barium chloride, followed by dilute hydrochloric acid. Complete the table below. A white precipitate is formed. The precipitate is insoluble in excess hydrochloric acid. What did we say about that? Let's look at it again. When we, like I said, when you see barium chloride, like I said, we agree that when we see barium chloride, what should come to our mind is the sulfate or the sulfite ion. They cannot just say a white precipitate is formed and they end there, because we have the sulfate ion giving us a white precipitate, and we have the sulfite ion giving us a white precipitate. That's why they went for that to tell us that precipitate was insoluble in excess acid. Precipitate is insoluble in excess acid, and that will give us the presence of the sulfate ion. This is it here. The precipitate is formed. The precipitate is insoluble in excess acid. inference, presence of the sulfate ion, the one with 4, SO4 2-. Give the chemical identity of A. We have identified the cation as potassium ion, and we have identified the anion as the sulfate ion. So the chemical identity of A is potassium sulfate. Potassium sulfate. So that's the chemical identity of A. We come to the end of our video. Note that when you use silver nitrate as the test reagent, what should come to your mind is the halide ion. Further tests will tell you which one precisely is present. When you see acidified barium chloride, what should come to your mind is the presence of the sulfate and the sulfite ion. Both produces white precipitate. Further information will tell you which one is produced, which ion is present. Insoluble in acid will give the sulfate, and production of sulfur dioxide will give you the sulfite. And when you see sodium hydroxide or aqueous ammonia, they are testing for the ion 2+ and the ion 3+. The ion 2+ produces a dirty green gelatinous precipitate, while ion 3+ produces a rust or a reddish brown gelatinous precipitate. Nitrate will give a brown ring at the center of the test tube with ferrous sulfate. Carbonates will give effervescence of carbon dioxide, which turns lime water milky. Water will turn white and hydrous copper 2 sulfate to blue hydrated copper 2 sulfate, and ammonia is a colorless, pungent gas that turns a moist litmus paper to blue. Thank you for joining, and see you in the next video.